Hello everyone, today I'm thrilled to share a topic that many of you are very interested in. Face swapping, but we're not talking about just any face swap. We're talking about high quality face swapping based on the Flux context model. Unlike traditional methods like PID or Instant IDA, which often show noticeable modelization artifacts, things like oversampling around the eyes and eyebrows, or that telltale plastic face look, Flux context completely avoids these issues. The quality of each generated image exceptionally high, with no obvious FX model traces. Imagine finding a beautiful face you like. With Flux context, you can swap it onto any character at any angle. The face's angle can change constantly during the swapping process, and there are no strict requirements for the subject's pose. What's more, the lighting rendition is absolutely stunning. You'll see perfect blending, even with complex lighting conditions on the target image. Let's dive into the workflow. It might look simple, but it contains a lot of powerful features. First, observe these two images. One is our source face, which remains unchanged, and the other is our target character onto whom we will swap the face. Let's run it and see the final face swap effect. As you can see, the result is quite amazing. Even if the hair colors are a bit different, the overall transition is incredibly natural. Isn't it? We can try another one. For instance, this one, where the hair color is more similar. Look how natural this becomes, and it supports multiple angles. Let's try a non-frontal face like this one, which is a complete side profile. See, the face swap effect is still incredibly beautiful. Not only that, if your target image has very complex lighting, this workflow can perfectly inherit it. Take a look at this image. You'll notice very distinct lighting on the face. After swapping, we still achieve a seamless fusion effect with beautiful overall lighting integration. Even though some of the original lighting on the face might be removed, the transition area ensures a perfect blend. So how is this quality achieved? The key lies in a specific element. This image, which is the face we want to swap, is essentially pasted onto the target image's face. Then our Flux model does its magic and swaps the face. The magic here is powered by a LoRa called Placeit. You can think of it simply as a pasting LoRa. This is what the Placeit LoRa page looks like. There's a basic example, although it's small, showing an image pasted onto a character, and the entire blending effect is perfectly restored. LoRa is also quite small in file size. Let's look at its recommended settings. LoRa weight recommended 1.0 or 0.9 image format. The image you're pasting should ideally be a square image. Overlay area should be aligned. Trigger word very simple. It's just Placeit returning to our workflow. We are ultimately processing this image. I'm using the official Flux DVX model. Here I've also added tick cache, because Flux context structure is similar to F, so tick cache can be effective and many extensions are optimized for it. Pay attention to the parameters. For Flux models, we recommend setting it up like this. It uses a dual encoder clip I and our T5 encoder plus RV. And right here we add our Placeit LoRa below. That is a standard Flux workflow process. We take the image directly, perform a Flux image scale to resize it. After scaling, we have a very simple prompt Placeit, which aligns with our LoRa's trigger word. Then we generate a latent image, which is merged with our prompt conditions. These are the official 2.5 settings. For the negative prompt, I'm using 0 tier, though you could use NG if you prefer, but it's not strictly necessary in this context. For the sampler, we use 20 sampling steps, ACF, G scale of 1.0, the Euler sampler, and the DPM++ SDE After scheduler. Decoding, you get this amazing effect. However, despite its simplicity, the main point is how this image is generated automatically. Many influencers discuss this LoRa, but they often use manual methods, like photos or other techniques to paste images. But mine is different, it's automatically generated. And we've tried so many examples. You'll find that the results are consistently excellent. We can try another one to confirm my statement. For example, look at this. Let's run it again, see the results. Isn't it beautiful? So this is not a forced technical solution. It's actually very stable. We've tried many examples, all run live, and you'll find that the generated results are consistently fantastic. So how do we do this? We mainly use two extensions. One, Face Analyze to auto crop face. These are very skillful to use. First, let's clarify the two images. This is the face to be swapped. This is our target image. This node is called Face Align or Face Alignment. The key is who aligns with whom. Notice where my image from is connected. It's connected to our source face image. An image 2 is connected to our target image. Clearly, I want to swap this face onto that person. So we must align this face with that one, specifically face part alignment. There's also an analyze model, which is the face analysis model we generally use inside Face. Of course, you can use Dribble, but it seems Dribble isn't installed on Running Hub, so we'll use inside Face for the provider. You can choose anything. CPU is sufficient because inside Face is very efficient. Some might ask what this does. You might not see it clearly by just looking. Let me change an image to one that more clearly shows what face alignment is for. For example, this image, look. It has a significant difference from the face. It's a complete side profile. Then we'll run it again, and you might be able to see the effect. You can probably see it now. Did you notice that the image rotated? This means if you want to align this face with that face, this image must be rotated like this. Then if you layer them together, you'll find that the faces can overlap quite well. So what does this face align solve? It solves the angle problem. Next, when we crop the face, we won't crop from here, we'll crop from there. So we use 2 instances of auto crop face. We directly crop this face. You need to pay attention. The first one is to crop the face from an already cropped image. Here we use a scale factor, which determines how large the cropped face will be. If you set it too small, for example, like this, let's run it. Look at the effect, the face is cropped so small. Pasting it like this would be meaningless, right? So this is used to set the size of the cropped area. I recommend setting it to 5.0 or above. I'll use 6, I forgot what I used just now. Remember, these 2 values must be the same. Don't use 6 for the top and 3 for the bottom. It won't paste correctly. The cropped face generally encompasses the head area. As you can see, the benefit of this is that I can ensure the cropped face has a fixed aspect ratio. There are many ratios here, but I recommend choosing 1:1. When you choose 1:1, the cropped face will be square, and this face will also be square. Now what we need to do is paste this face onto the target image. For this, we'll use a node called Image Paste Crop. When you crop this face, each crop will have an output 1. This output 1 is a dataset. What kind of dataset? It's a crop dataset. This crop dataset contains both the size of the crop and its position, similar to a bounding box. And pay attention, this node is very tricky to use. Your goal is to paste it onto this image, so for the image input it must be the target image. This remains unchanged. And whom do you want to paste? Of course, it's our source face image. So it connects here. The key is the crop data input. Which one do you connect? This must be very clear. My crop data is connected to this one, meaning the crop data from the target image. Essentially, I am scaling this image, the source face, to the same size as the target face, and then pasting it at the same position as the target face. And that becomes this. So these notes are the essence of this workflow. Many people might find it confusing. Therefore, sometimes we indeed need some mathematical or programming mindset. Of course, this can also be a bit smaller. Is this a bit too big? I forgot what my previous setting was. Let's try 5. You also set this to 5. Let's run it again. I think 5 might give a better effect. 6 is a bit too large because the more you cover, the smaller the reference area becomes. If you crop too little, then issues like hair transition might arise. So you just need to experiment with this yourself. Main thing is to understand how this note generates the output.